Oh, oh, hello. Hi there. Hello, everyone. Can everybody hear me? Yes, okay. Seems a bit low. I just want to welcome you all to another launch pad. My name is Aaron, and I work at Foo Café. And at Foo Café, we do great events for the software community. And Launchpad is my own initiative that I have done as a way of kind of connecting people who are working in the same area. I should say it is for anybody with an interest and passion for tech, IT, AI, software development. And I can see a lot of people here. Some are students, some are at the beginning of their journey, some have been working in software development for many, many years. And we have companies here today. We have Saab, who is going to be doing a presentation and panel discussion. And the thing is here, we're all here because we're all interested in this area, and we're all equal here. So we're all here to learn and share with each other. And I think it's so nice to see when people come and they get talking to each other and they start doing projects together. And over the last couple of months, I've got to know quite a few of you, and it's been so nice to get to know you more and find out what you're interested in. And you've gave a lot of great feedback to me about this project, and it's been so great to do it. And so thanks to everyone coming tonight and all the support. And thanks to Saab, and thanks to Michael, who's here somewhere. Hi, Michael. So that's enough for me. I'm going to pass you over to Olof, who's going to give us an introduction and tell you all about the event today. Thank you, everyone.
Thank you, Aaron. Okay. Hi, people. I'm Olof, and I work at Saab Aeronautics here in Linköping. And we are a few people from Saab here. Apart from me and Jenni, we also have some people over there in the corner. Say hi to the audience. And we will hang around here afterwards. So if you're interested in talking to us about something or asking questions that you are afraid to ask in front of everyone else, please feel free to look us up afterwards, okay? Great. So the agenda for today looks like this. I will do a very brief introduction of Saab Aeronautics, I promise you. And then Jenni will talk about some examples of AI and autonomy projects that we do at Saab Aeronautics, just to give you a feel for what we're up to. That will also be quite brief, because then, of course, we will have a panel discussion with Jenni and two other people that we will introduce to you later, okay? And feel free to interrupt and ask questions and so on, because we want this to be a discussion and a dialogue. And for those of you who are with us online, Aaron will try to keep an eye on you. And if you have any questions, just enter them in the chat, okay? Great. So, Saab Aeronautics, the business area for big flying things at Saab, okay? Because we have 4 business areas at Saab. We have Saab Aeronautics, we have Dynamics, they make missiles and smaller flying stuff. We have Surveillance, they make radars and sensors and things like that. And we have Kockums, they make ships that run on the surface and below the surface. So that's Saab in a nutshell. We were founded in 1937, and we at Saab Aeronautics, we are now close to 7,000 employees, I think, because for well-known reasons, we're growing quite rapidly, okay, unfortunately. And at Saab Aeronautics, we have 4 business units. We have Gripen. I think most of you know about Gripen, our fighter. And then we have aviation services, because we also have to maintain aircraft, both our own and others. And then we have aerospace systems, and they build stuff mainly for other industries. So they manufacture doors and things like that for other and parts of aircraft. And then we have advanced programs, and that's where Jenni works, right? Because that's where we do forward-looking stuff, Saab Aeronautics. And we have production here in Sweden, but also in Brazil and the United States. And that's it. Okay. I'm finished now. Any questions? Right, so let's move on to Jenni then and talk about some more interesting stuff. Welcome, Jenni.
So my name is Jenni Reuben. That's not a made-up name. It's my given name. So we can keep aside what's your real Indian name question. So yeah, I'm a research scientist at Saab Aeronautics in the Advanced Program Business Unit. I excited what I do, not because that I have to work on any cool application or a technology. It's because to keeping people and society safe. As Olof mentioned, Saab has been in aviation domain or aviation also in other domains since 1937. And this is the quote from our CEO. Saab is committed to protecting societies and strengthening the European defense capacity. So I give you, we jump straight away into one of the way of working in the Advanced Programs Business Unit through an example project or a knowledge platform. So the principle is to fail often, fail forward, and fail fast. So that's the principle that we have or one of the way of working. And Urdabrunnen is a knowledge platform. So it is set up to accelerate mission autonomy. And what do we learn in this platform? So 3 things: architectural design for mission autonomy. And we also try to put our solution into practice in simulation and also in real world to understand the flight dynamics. And then the third one is to demonstrate complex scenarios, like challenging scenarios, by putting that into practice. So I give you one example pilot project that was driven by a use case in the Urdabrunnen project. It's about object detection. But then the use case demands that the search and rescue mission is conducted involving both military sites and the public site. So how to have a global object detection model for a UAVs or multiple UAVs that are involved in the mission that can recognize and detect object in all these multiple sites. So the challenge here is to build a global detection model that is used by all the UAVs, given that the data is having this different tiers of security classification, and the data is locked in different silos with military data infrastructure and then the civil infrastructure. And each actors in the federation or in that are going to do the mission having small amount of data to train a machine learning model. So then we use federated learning. If you had heard about federated learning, we use federated learning to train a global model that can, in which all the clients that come into this federation doesn't have to share the training data with each other or with the central server. So next I show, again, to keep it very brief, I show the results from the federated training to train an object detection model. So the precision and the recall, and then the MOP metrics from the pilot project. Here you see the curves from the clients, so how they are converging into to give a global model that can be used by all the clients, even though they didn't share the data with each other. So that's one way of working: fail fast, fail often, and fail forward. And next or another way of working in the advanced program business unit is to take an idea and then rise the TRL level of that idea. TRL level is this technology readiness level. And here I'm going to give you a bunch of applications that is categorized categorized into different category that we at Saab Aeronautics use: AI for products, AI for operations and logistics, AI for development, and AI for everyday productivity. So different machine learning applications, different AI and ML applications within Saab Aeronautics that are gathered into these different categories. Next, I also will give you again a list of applications, autonomy applications for forwarding or advancing mission autonomy. So autonomously to carry out a mission. The mission that I showed you is search and rescue mission, but it could be any other mission to how to do this autonomously. So there we are working on different projects under the category like trustworthy and dependable systems, enhancing pilot capabilities, platform technologies like microservices, digital twins for training and simulation, or to generally have a common methodology to do ML training. That is also learning we are trying to gather from at the knowledge level, to gather from the projects. And then last, mission and human and mission teaming. But we are very humble about advancing autonomous fighter technology or capability. So the challenges here are to have an ontology or a generic structure for autonomy, because Olof said that we have naval autonomy also within Saab. So to have a general autonomy structure is quite a challenge. That is also we are working on. And then the health management or introspection of unmanned autonomous platforms. And dynamically replanning. So when it comes to mission autonomy, when the autonomous system is out doing the mission, how does it, by seeing the environment, how to dynamically replan the mission, for example. And also challenges from the regulation and ethical aspect, to incorporate that when we are designing and developing autonomous systems. And last, human mission teaming and cooperation. How to align intention between a human and a mission when they collaboratively do a task. So these are some of the challenges that I wanted to present, that we continuously keep on working in our projects. And that's a brief overview of what we do at advanced programs or Saab Aeronautics, you could say. And I take questions if any. Thank you.
Okay.
So, thank you very much for the presentation. A quick question. You mentioned that you had like autonomous planning for your missions and such. At what level is this? Is it like task planning, motion planning, a mix?
Yes, strategic planning, so the mission planning, but that consists of, again, planning, path planning, obstacle to plan against the obstacles. So both at the low level and then take it to the mission level also, strategic planning mainly.
Okay, thank you very much.
Okay. And anybody else like to ask a question? Yes, Alfred. There we are.
I have a quite, maybe it's a stupid question, but I guess it's often from the plane's perspective, like when you move the autonomous vehicle, you are planning on how to do things. I saw a quite funny thing regarding chess the other day, like how the opponents work and how you like see their training and also take that into consideration. How much AI is into like determining how the opponents, in this case other fighter jets or other drones, for example, operate?
Yes, without giving you a lot of details. We have a project, so reinforcement learning is a good example to have that kind of knowledge baked into the model, so that always you have this reward that learn what the opponent might think, and then you get a model. So yes, we use AI or machine learning to get that knowledge. Yes.
Interesting. So it's like a two-way game in a way. Like, how should we act and how would they act? And then from there you do your actions pretty much, I suppose.
Yes. Yeah. So when you take an action, you're optimized to take an action that the opponent may, or you can outrun your opponent. So then you're rewarded. So for that reward model, you take definitely into account the decision loop of your opponent. Yes. I don't know if you heard about Project Beyond. Yeah, that's a good example for that use case.
Cool.
And any more questions? Okay. Thank you. Great. So,
Actually, for those of you who are interested in advanced programs, we plan to do a launchpad on diving more into advanced programs and what we do there later this year. So if you're interested, I advise you to come back then. Okay. I guess now we will do some moving some furniture around and prepare for the panel, right, Sharon? Okay, now we will also see if we can actually sit in these armchairs or if they're just decorative. So that will be interesting. Okay, excellent. So for this discussion, I think you will recognize the first speaker if your memory is not terrible. Jenni, welcome back. But also we have two non-Saab guests here to get some more flavors on AI and autonomy. So Isabelle, welcome.
Hello, everybody.
CEO of Yvarbrims, and of course I knew right away what that means, but for the audience maybe you can tell them where that name comes from.
It's completely made up. No, it's there's a logic behind it. So I'm originally from the island of Gotland, and my passion in life is unmanned aircraft. So I decided I want to create a company, but I don't want it to be named Sky something or Drone something or Aerial something. I want it to be unique. So I went to the local Gotlandic language committee in 2016 and I said, what's drone in Gotlandic? And they came up with Yvarbrims. It means the buzz from above. So it's not completely made up. I know it's not the easiest to pronounce or understand, but it's a homage to drones in Gotland.
Great. And also from the University of Linköping, Mattias, welcome.
Thank you so much.
Right. So, actually, I think we should start with a very general and open question. So let's see if we have time for more than that question, depending on how brief you are. But I wanted to ask you what autonomous flight. What does that mean, actually? Because that's what we're going to talk about today. No, when would we see autonomous flight? But with bigger things, things with people inside, like passenger aircraft. But to talk about that, I suppose we need to decide what autonomous flight is. So if we start with you, Jenni.
Yeah, in the work I do, autonomous fight or autonomous airplane aircraft is an unmanned system that demonstrates some kind of human-like intelligence in its behavior to pursue a goal or an objective. Yeah, that's what I call an autonomous.
So it doesn't need to actually fly itself. So that would be fully autonomous, right? Or if you don't have any humans involved in the actual flying. Right?
Yeah, fully autonomous.
Yeah.
Yes. That's also something that's I'm working right now.
Yeah.
So we where is this level of human intervention in this autonomous flight? So at Saab we refer to 5 levels of autonomy. One is the first level of autonomy is controlled, like a human pilot controlling. And then the second level is directed, so every action is directed. And then the third level is human in the loop, human in the loop, that is delegated. So some decisions, some tasks are delegated to the autonomous system or subsystem. And then the fourth one is the monitored. So everything is taken by an autonomous system, but there is a human behind monitoring every action. And then the fifth level is the fully autonomous level.
Okay.
Yes.
Great. And same question to you, Mattias. Autonomous flight.
Yeah, so I'm thinking about fully autonomous aircrafts now. Of course, from the AI research field, we also talk about degrees of autonomy, and you can't really have something that's an AI agent or advanced technology if you don't have a degree of autonomy typically. But from the perspective of autonomous aircrafts, then I would expect these kind of things that are in fairly reasonable future near term to be aircrafts that operate fully autonomously in terms of taking off, landing, and so things like that. But I would also expect us to have people that actually monitor them and make sure that they are compliant with AI Act, and that can actually take over at certain levels of operability depending on issues that happen, like external events happening, like a meteor rain or some kind of visit from Russia or whatever.
Okay, so not just a sunny day scenario.
No. Exactly.
Great. Isabelle?
Well, it depends on who you ask. So
I'm asking you now.
Yeah. So in my realm, I work a lot with startup companies that develop and design drones, either the small ones that you can buy at your local electronics store, but also bigger systems that are made for surveillance. And the levels of autonomy there are not so defined yet, because you can easily buy today, anyone here in this audience can go and buy a drone which will take off, land, perform a route autonomously. But you still need to have some level of human intervention. So it is not fully autonomous. The goal is to get to a point to have fully autonomous systems flying without any human intervention. But I don't think that we're going to get there tomorrow. I think that the road there is quite complex.
Yeah, I can imagine. Okay, great. So just very briefly, because you have different perspectives, what's top of mind for you at this moment when it comes to AI and autonomy? If you can sum it up in a few words, Jenni.
Yeah, the levels of autonomy. So increment is the key. So from going from human in the loop and then moving on to human on the loop, that there is always human. But there are other challenges. If you for example, if the human is not trained, the operator is not doing this kind of activities, the task, maybe the skill may go, there's a term for it, I don't know. So then we have to keep up with our training to also to control the system.
Okay.
Yes.
And Mattias, what's on top of your mind?
Yeah, it's how we can realize autonomous systems that works in the open world. So where we have new things that happens that we didn't think about during design time or when we built the system or wasn't present in the training data. So how we can build systems that can operate even when things changes and are different, so that they are built to handle unknowns and unknown unknowns in a robust way and trustworthy way.
Great. I think we'll come back to this, but Isabelle.
So top of mind in my world is a combination, kind of another dimension of what Jenni and Mattias are describing. But we are looking at the stages of AI and kind of autonomy integration, because you need to look at it not as a system that just automatically, performs a flight. There's so much more than just a flight. There's the pre-planning, there's the post-flight, being able to analyze tons of data in order to take a decision before you put an aircraft in the air. And that's where I think most people are not focusing as much as we need to, and that's where the big potential is to have, a smarter, more efficient way of taking decisions with a mix of human intervention. So we're kind of in a very early stage of trying to see what are the different levels, what are the different phases, and to what extent do we actually want to integrate this.
Okay. So we're at the early stages now, but without perhaps mentioning any time perspective, what would be your long-term vision or goal for autonomous flight, Jenni?
Simple, to take our pilots out of the battlefield.
Okay. Completely.
Yes, yes.
Yeah.
Oh,
Yeah.
that's the long-term vision.
Mattias?
Yeah, I mean, tying back to what you said here, to optimize the entire flow of people and cargo, and to make sure that it's both, efficient and cheap enough to be utilized at its full potential while leaving a small climate footprint as possible. So, really not just optimizing and making sure that the flight of a single aircraft is, really good, but for the entire global system. I think that, and also make sure that we keep on improving it beyond what any single person, single group of persons can actually do on their own.
Okay. Thank you.
So, sorry, just a quick question to place everything in context a bit. I think most of us know Leo, and I think most of us know Saab, but could we have a quick introduction to what Ivabrims does?
Sure, yeah.
I thought everyone knew that.
Wasn't it obvious? No. So Ivabrims is a consultancy that I started based on that I've grown up around drones. I've worked with drones operationally in the field since 11 years. And I wanted to take all of that knowledge, all of those lessons learned, all the failures that I've done in the field, stood crying over crashed parts because we didn't have good processes. That's something that we've had to manually create. And now we've come to a point in time where we have the ability to introduce better processes. So I started my company to help other organizations fly. I'm no longer a drone pilot out in the field, but I'm helping other people find access to the right hardware, software, to be able to collect data and deliver from point A to point B using the right tools, because it's a bit of a jungle. So yeah, that's what I do.
Thank you very much.
Thank you. Right. So the question was asked to Jenni and Mattias, but we also want to hear you, Jenni. What's your Isabelle? What's your long-term vision or goal with autonomous flight?
My long-term vision and goal is to see that currently today, let's say that we're in this kind of general state of everybody seeing a drone as either a tool a toy or a military weapon, but there's a hole in the middle there where it's actually a tool. And we don't have the general mass public understanding that yet. So my kind of realistic goal is to make these day-to-day drones standardized to the point that it's no longer a jungle to navigate it, and it's a given that we use this as a tool. But long term, I would love to see autonomous passenger aircraft being able to take me to the hospital one day if I'm lost out on Gotland and there's no space in the Visby hospital. Then I would love to see an eVTOL be able to take people where they need to go.
Yeah, but you wouldn't get lost on Gotland, though. No?
You never know.
Okay, let me ask you, how many of you consider yourself software developers here? Yeah, quite a lot. I thought so. So that's why I thought I would ask you, perhaps Jenni and Mattias most, but you're free to of course, as well to answer. But what's the when you develop AI functionality, does that differ from developing traditional software? and maybe in particular in our case, software for, safety critical software for aircraft. Does it differ?
Yes. Or
You can start if you want.
Yeah, I jumped in because currently, if you develop an airborne software, the primary standard is the 178C, DO 178C, which laid out the safety objectives, laid out the design objectives and the requirements, the processes, the activities that has to be followed to develop an airborne software.
Because
But
otherwise the authorities won't allow you to fly, right?
Exactly. You don't get an airworthiness certificate if you don't follow that standard. But when it comes to developing a machine learning model, that standard falls apart because of 3 reasons. One is the black box nature of the machine learning models. You have this billions and millions and billions of parameters. How do you trace back? Because this 178C, DO 178C, it emphasizes bidirectional linking or tracing of requirement to the logic of the software. Why is the software function this way, or what is the logic of that function? But when it comes to the machine learning model, you have this black box nature. How do you trace back from the output to this millions and billions of parameters? And then the second challenge is, again, the parameters are not having any fundamental principle. They are automatically learned from the training samples. So then you cannot even connect the requirements to the fundamental principles. So you don't have any. And the third one is the complexity of this intermediate knowledge representation. You see the output, you see the input. And how do I validate the performance of the output if I cannot interpret what is what is happening in the middle? So those are the differences. But luckily, experts are gathering to find or to construct a design standard to certify a machine learning model. Yeah.
And one of those experts is you, so we'll get back to that later.
Yeah,
Okay.
Thank you.
Matthias, you want to add something?
Yeah, so when you develop a software system, typically, you have a specification, you finish it somehow, you might discover some bugs, you might have some feature requests, you update the software and so forth. But if you have machine learning components, then the development never stops, because the data that you trained the machine learning component on will become old or no longer valid. You will have distribution drift, concept drift, a lot of possible issues, because the world changes, the people that use it, the users that use the product, they change their pattern, the global economy changes. You have these kind of special events like COVID or conflicts, and the organization changes as well. So you need to always keep developing. So maintaining a software system that includes these components means always continuously developing it. And then you also have this additional uncertainty due to the data. So you're using data as a surrogate to try to describe the pattern you would like to be there in logically, because you don't know how to describe it explicitly, or because you're too lazy to do it. And that means that you don't really know what the performance is going to be until you have actually trained the model and put it in some kind of operational context, which means that you have increased risk due to this increased uncertainty. And even if you don't use machine learning based AI approaches, you can instead use systematic AI approaches that uses search optimization and these kind of things. And then the software systems themselves are very adaptable, can generate really complex solutions because they are solving very general problems. And that means that they are also really hard to understand, even though they are white boxes. So it's tricky to build human intuition and really make sure that everything works as accordingly. We have methods to, especially with the systematic AI approaches, but it's still difficult to wrap your head around if you're not, in that space. And of course, there are huge challenges with data-driven approaches. And this is difficult even if you're in closed environments. Like if you want to have a robot, walk around here and be able to do correct object detection and pixel segmentation. Imagine then the open world where we have no chance right now to collect a representative data set. So it will not be robust. It will not generalize. So we need to have additional helping systems surrounding it right now, including humans in the loop, to make it effective and useful. And that also needs to evolve and adapt. So it's quite a challenge, even though it's really rewarding because you can accelerate and make things you couldn't do before.
Okay, so apparently there are challenges. We can sum it up that way, right? But what about for you, Isabelle? I mean, you mentioned that you have worked as an operator. You have been in the drone industry for quite some time. What are the current challenges from your perspective?
Where to start? No, we have gone through, so let's say that the commercial drone industry has been around for about a decade, but the concept of drones itself has been around much, much longer. Actually, I would say 60, 70 years, if that even is enough. But it's something that's crawling closer and closer into society, something we're aware about. And the more they become popular and the more they become accessible, the bigger issues we introduce in having now large numbers of aircraft in the air. And now ideas of let's take this small thing and put a human in it. So let's just scale it up and let's, put it in cities. It's all introducing risks that we do not yet know how to mitigate in every aspect. So we're at this kind of crossroads of having technology, which is very advanced, but we're not sure how to regulate it. And it's today very hard to scale that because we need more tools to actually bring in the safety aspect and be able to reduce the risks involved of introducing the technology in this kind of environment with factors that you don't always have control over. So finding the expertise to hire to create these solutions, finding the space to test it, finding creative ideas and thinking outside of the box to actually drive this development to find a scalable industry. Those are the key challenges.
Okay, and the last point there, would that be, do you think that's a shared challenge between the industry and the authorities, or is it?
Absolutely. I mean, this is not a new technology, but it's new the way we're using it. So it's an immense challenge for every regulatory body, whether that is EASA, which is kind of the umbrella for our regulation, but even on a national level, you have to find people that can actually understand every detail of introducing the technology at a wider scale and being able to then create processes for people to follow. There's always going to be backlash from operators saying, oh, the regulation is so slow, it's so limited. There's a reason for it, and we have to be patient. It's going to take time, because the more types of transportation that we introduce into the world, the more complicated it gets, and the more it needs to find a symmetry to actually work together. And we are just kind of at the start of that. So there are a lot of, let's say for every solution, there are 100 new challenges, and we are diving into all of those, but we need more people to join in on that.
Okay. Right. I have to get back to you, Jenni, because you mentioned, of course, that there are experts thinking about how can we actually, allow an autonomous aircraft to fly. I mean, how do we change the current regulations and so on? And I know that you're involved in a working group looking at these issues, right? Can you tell us a bit about that?
Yes, so this working group consists of experts from different industries or different companies in the aviation domain to design a standard similar to DO 178 that consists of objectives, processes, and safety objectives. And how
and just to remind us, DO 178 is used to create traditional software for aircraft.
So similar to that, we are trying to construct a design standard. So long story short, we have like EASA tried to produce, like in the traditional safety critical software or airborne software, we use a V model, so life cycle model. So you develop and then you validate. So EASA now introduce a W model. So that covers the data, the training data, and then the model development and the inference. So the data and then the middle bump is the model and then the inference. So there are 5 processes. Briefly, I tell you. So one is the characterization of the ODD of the ML system, and then the data quality requirements. And then the second one is the data management processes. And the third one is the ML model design and optimization, the training. And the fourth is the the model verification, and fifth one is the model ML system validation. So we give the process and the safety objective for these 5 different things.
Okay, so
Yes.
Before we take a question from the audience, how far along the road are you at the moment? Can I develop an AI functionality tomorrow and have it certified using this?
Yes, ESR use this as a means of compliance.
Okay.
Yes, already one of the means of compliance, but usually they have this one standard, like 178 for the traditional software. This ARP, if the first ballot is done, so everybody is voted for it, for the content in the standard. It's a very long standard. So they use this as a means of compliance right now to, for example, detect and avoid application from data island. ESR use this the content that we are developing to certify. Yes.
Great. Yes, please.
All right. This is highly interesting this far. But I have a question that is more of the ethical nature in this case. Let's say that we in the future have autonomous aircraft, civilian, military, and so on. They work according to their programming, but they also have autonomy. They are adaptable. They will make changes and their own decisions based on something we may not be able to predict. If they do something that's out of bounds, unethical, they do something wrong, who will eventually be responsible for that action and the outcome of it?
No, Mattias, please.
So there is some groundwork there already in the AI Act, where you talk about different responsibilities and that kind of how different stakeholders should take responsibility. I mean, it's not clear cut, but there's starting to be some kind of solidifying foundation there, including both everyone from the development side doing the specific development up to the people that actually deploy it and use it. And you have certain expectations on all these stages so that everyone should be able to work within their capacity and understanding, actually make sure that you are compliant with humane AI and ethical AI standards. Then, of course, someone has to take responsibility for the whole, I guess, too. That's a bit less clear, but there we have this kind of certification processes, and eventually, I suppose, the state actors or even the European Union in some sense is going to have to take some kind of responsibility. But it's still open, not just in the aerospace industry, but also in the automotive industry too, of course. Then, as you said, it's really interesting. It could, basically leave this kind of, say, envelope of what we designate as ethical or even safe or even acceptable in some sense. And one of the things that is super important for these kind of systems is that they need to be able to monitor themselves whether they are inside or outside this kind of safe, allowed, and suitable envelope at all times, so that you can have immediate recognition, immediate action being taken, not just of themselves, but also probably of the other drones. Like with the opening up of U-Space, about 100 meters above the surface level for drones flying in all of Europe, we're going to have hundreds of thousands of drones potentially flying above Linköping city. Some of them could be owned by criminal elements. So suddenly they might decide that that person needs to be followed, or we're going to go down and try to create some hurt. Then we need to have some kind of mechanisms to self-regulate. So these drones might need to be able to observe each other, monitor each other, and actually maybe do some intervention if there are any drones that are going out of not behaving as they should. Because we have recent research, for example, from my group, where we can right now create near optimal paths that are collision free for thousands of drones within a second. That can be scaled to a few seconds, and you can have tens of thousands, hundreds of thousands of drones. And so the techniques are there. We can do it, but how do we do it ethically and in a way that is sustainable?
This is a super interesting question, and I think we can have definitely a whole panel on just this. But but like I said, we will be here afterwards as well, so you can look us up and have a discussion. Yes.
Thank you again. So have a step back to the regulations for the AI software, which Jenni presented. My feeling was that was all like external to the model, right? The evaluation and such. And famously, interpretability and mechanistics, explainability and such is way behind. But has there been any discussion of trying to like mechanistically look at the models and such?
But that's very limited, right? So mechanistic interpretability, I think the last thing I checked is ChatGPT 2, or yeah, so it's very limited with those kind of methods. So it's not outside the regulation. We give the processes like for testing, where do we put, so I said this W for the training, and then the model design, and then the inference. So for each of these three parts, so there is processes, how rigorous the testing should be. So for when we develop a software, so we assign a development assurance level for that software. So the kind of rigorous testing that needed for that particular software. So how much does it involve in the safety of the flight? So if the model that we are developing is going to be directly connected to the safety of the flight, then the design standard gives you processes that has to be followed. Then the authorities certify that. So I don't know where did you why it's not external. So you follow the process when you're designing and developing. Yeah. But or you as a manufacturer or as a supplier of a model, you can choose your method. If you want to choose mechanistic interpretability, then you choose your method. But then you have to fulfill the safety objective that is defined by the regulators. Yeah.
Sounds like a good way of going about it. Thank you very much.
Thank you.
Yes, we have one more question over there.
Thank you. I think it's massively interesting discussions so far. Jenni and Mattias, you were talking about training these models based on the output without actually like knowing everything that happens in between. And I suspect this is as much a statistical problem as a software problem. And you, Mattias, said that like there are methods to like interpret this data. Would you care to elaborate a bit on that?
Yes, sure. So depending on what kind of data, we have methods that are really good. So for example, for regular signals, physical signals, like most sensor fusion, things that is needed for control and things like that, we have really good methods and technology that can allow us to do proper anomaly detection, auto distribution detection. We have robust machine learning that is trustworthy, can be integrated with the, physical domain knowledge and all these things. We can build really safe controlling systems that use these kind of low-dimensional, physically near signals, information streams. But on the other hand, when we think about like perception using computer vision from cameras and radar or text and audio, we sacrifice all these nice properties in order for getting our machine learning models to scale. Which means that one of the most tricky things is to try to recover some of them, like robustness or distribution detection, anomaly detection, these things. And there are methods like conformal prediction that can allow us to quantify uncertainty, which is good because then we know like what is the variability of the outcomes if I take this action. Are we going to likely to crash, or is just likely to wiggle a bit, for example? And the problem with those methods is that they only work in distribution. So if we are in a situation that is similar to what we trained on, then the calibration of uncertainty is correct. If it's dissimilar enough, then we have no idea. So that is current kind of the boundary of what we really can achieve, which is also why the European Union doesn't have autonomous vehicles, whereas the US has, because they have different ways of viewing these kind of risks and things like that. And this is really tricky. In the open world, if you're in an industrial setting, you control the environment, you can make sure to have a representative data set and that nobody's hurt, everyone is trained. But out in the street, children running around or potentially in the air too, it's much trickier.
Yeah. Thank you.
Yeah, we're actually running a bit out of time, but I have to ask you mentioned that it's easier, of course, if you have like a known controlled environment, but And Isabelle, you're working mainly, at least, with unmanned vehicles, right? Unmanned drones. Does that make things easier? I mean, regarding AI and autonomy, what do you think?
There's a saying, there's nothing unmanned about unmanned. And that kind of rings true because it does make it easier to integrate because there are so many places where you do need to kind of, you have to create a less manual process. Again, a drone can fly 20 minutes and it pretty much can, do what it needs to do on its own. Someone needs to monitor it, but it's all the work before and it's all the work after that can be automated. And that's where we need more AI tools and integration. So again, the expertise to get there and the ideas on which moments to automate, they're freely welcome because we need those tools. As an example, an operator who is maybe sent out to do an inspection or survey or mapping project of something, they will spend maybe 2 hours in the field, but they will have spent maybe 6 hours, 10 hours, 2 weeks beforehand planning because they have to manually click around and collect all of this information. How is the airspace? How is the weather? How is, all of these risk factors involved? This could be simply automated. We have all the tools existing to do this, but we are not doing it. So it's a lot of the pieces of the puzzle are here. We just need to put it together. But I think we are getting there one step at a time. For example, one project that I'm working on is together with Kista Science City. They have a project called City AM, where we're looking at how we can integrate drones in a city environment. So all of these uncontrollable kind of factors is something that we're looking at, how to go through the process of actually planning to integrate this, and then what kind of issues do we run into? So how do we make it easier for the next city who says, we want to have drones in our city to look at traffic analysis? And it's these kind of projects that are the stepping stones to actually having an opportunity to test and to gain this kind of data for the next company or the next organization to use and build upon. So we need more of these opportunities to actually push it into an action, not just a theoretical thought.
Okay, so you mentioned a few times now that you need people, right?
You need people.
So what if I want to be part of this, how do I go about that? I mean,
if you want to be part of this development, in regardless of which aspect, there are so many pieces of this ecosystem. We need people that are out in the field. We need people that are behind the computers and creating genius programs and ideas and processes. But all of these pieces of the ecosystem need to kind of understand one central thing, and that is what the technology is, what it's intended to do, and how it's connected. What are the framework to work with, the regulations, and kind of identify where are the missing pieces of this puzzle and just jump in. There are tons of companies here in Linköping, in Sweden, in Europe, around the world that are working on different solutions. So if you find something that you're passionate about, or, oh, wow, this sounds like a really interesting solution, or this is an interesting issue that we should find a solution for, connect with companies, LinkedIn, connect with us. I think power of the network is the best way to kind of jump in and see what's going on in the industry and where you might want to fit in. I think it's a very Swedish thing to kind of be quiet, but there is a lot of space to take up space and be loud in this aspect of AI and autonomy and drones. So please feel welcome.
Okay. And what if I'm more interested in the research area?
Yeah, sure. So one of my frustrations is that the university doesn't have a really good way to really do the knowledge transfer of this kind of state-of-the-art techniques, especially on the applied AI side, because we're not really supposed to do that. We are supposed to do fundamental research or have this kind of larger research projects. And our courses are lagging a bit behind and also often aren't really touching the real-world requirements and processes or even data sets. So I mean, I would encourage you to, if you want to really get the latest things and how to apply them, you could apply it for industrial PhD programs. Become a PhD student that is actually grounded in a certain industry and certain application area, such as flying aircraft, for example. Or you could request through Uppdragsutbildning to have advanced courses that are also applied. or you could, try to find collaboration areas. There's a lot of knowledge that is locked in, that is not just theoretical but actually applied, that could build and enable a lot of what we talked about here today. But there isn't a way to actually do that today.
Okay, great. Now we have to round things up, but we really cannot quit without answering the fundamental question, right? So very briefly from all of you, Jenni, when will we see fully autonomous passenger aircraft?
Not soon. Not soon, in my opinion. It's not only the technology, as Isabelle and Mattias been pointing out. It's not only the technology. The technology is here. The infrastructure, the test sites, or the maintenance processes, and all this have to be in place to make this dream to come true.
But give me a date.
I don't want to bet on it.
Okay, a decade then.
Yeah, or more than that.
More than a decade.
Yes,
Yeah.
because
2
EASA,
decades, 3.
EASA even changed the level from autonomy to automation. So we begin with Saab has this level. EASA has also levels from AI assistance and AI collaboration, and now they changed the autonomy, the third level, to AI advanced automation. So it will take time.
You're dodging my question now. Jenni, I realize.
Okay, so 2 decades.
Okay, 2 decades.
2
great.
decades.
Isabelle.
I think we will see the concept of passenger autonomous aircraft.
That's another way
sooner.
of dodging my question.
Well, yes, it is. To have it fully autonomous, I think at least 3 decades, and that will be in a very small scale. I don't think we'll see it everywhere on that level, but where there is a need, I think we will see it sooner.
Okay, so perhaps your rescue mission.
When I'm too old to walk around Gotland, I hope that we will see an eVTOL or something in, let's say, 30-40 years.
Okay.
Yeah.
Mattias, you agree?
Yeah, in some ways we already have autonomous aircrafts. It's just not safe to use them without pilots. Just like with autonomous vehicles. On the other hand, when will they be safe enough to be used without pilots and only have a limited, crew monitoring? It depends. If we are lucky, it could be 5 years. If we are unlucky, it could be, at least a little bit earlier than autonomous vehicles. And the meme is of course 10 years. So I would go with 10 years.
Okay, thank you. Well, we'll stick around for you, but
There's one question.
okay, we have time for that.
Yeah. I was so curious regarding the things you said around the flight, Isabelle, like all the things you have to do before you fly and after you fly and so on. And this might be a little bit of an unserious question, but as a Star Wars fan, I must ask, like, how is robotics integrated into these flights? Like, how far will we have our R2D2s helping us?
Someone's also working on that. To some extent, you have already drone-in-a-box systems with a robotic arm that will switch the payload, that will switch the battery, so you don't need to go and offload and unload and do these things. That might be over-engineering part of the concept, but there is a reason for it. If you look at, for example, logistics, let's say you want to ship organs or blood between hospitals, you don't want to have too many hands involved in that. You want an automated, ground robot taking the, delivery to the drone who will then take it. You want to minimize all human contact in that loop. So we do have reason and need to have kind of robotics involved in this as well, but maybe not in every case. And let's maybe keep it indoors because it's a bit easier. So, yeah.
In our field robotics lab, we have small drones that are attached to large drones by ground vehicles. Not robustly, not production grade, but similar thinking to have this kind of rapid response for a crisis scenario and helping, like rescue workers. Yeah.
But if you develop the R2D2, I'm sure Isabelle can develop the drone to attach it to, right?
Yeah, absolutely.
Yes.
Yes.
All right. Well, thank you very much. Thank you, Jenni, Isabelle, Mattias, and thank you for joining us. I guess now it's time for something completely different.
Yes,
Aaron.
absolutely. That's it. So that's the presentations part. Big thanks to the panel, and thanks for the questions. But let's keep the discussion going over some food and drinks. We're sharing, but we have plenty to go around. So yeah, talk to somebody, and think you'll be around for the next hour or so to answer some more questions. So yeah, let's do that, and I'll get some drinks. But thanks again for that, and thank you.
Thank you for organizing.
Yeah, thank you.